first thing that you should be thinking about is pulling out a greatest common factor. That can simplify your life a lot. If you've noticed that you have only two terms, you're probably dealing with the difference of squares, the difference of cubes, or the sum of cubes. If you have a three-term equation, then you're going to notice that your front term, the a squared, the a coefficient, you want to see that is a 1. If then you can just jump right in and start FOILing it. Or if it's greater than 1, you will want to think about splitting the factors. In that case, those were the steps for splitting the factors. And there's one part in it, in this area here, where you've got 4 terms. And that would lead into the 4 terms you can factor by grouping. We did that on as one of the steps on that splitting the factor. Then we have our technique of completing the square. And if all else fails, we've got the universal quadratic equation. Applying the thinking pattern comes in handy when you actually start to work with factoring. And most of the time, it occurs in fractions, where you've got several terms, a binomial, trinomial, a polynomial, as a term in an addition, subtraction, multiplication, or division problem involving fractions. That's the type of problem that I'm talking about. These binomials and trinomials are attached to each other through these plus and minus signs. You can't look at these in separate ways. They're connected to each other and they have to be factored. If you had something like this, x squared 25x squared y cubed, you could separate this out as 5 times 5 times x times x times y times y times y, and they could all be used individually. That's not the case with addition and subtraction when the terms are attached like this within the trinomial or the binomial. They have to be factored. They have to come out as a group. So it's a little dicey when we go to multiply the whole grouping of them. They have to be broken up. So in this case, x squared minus 25, it's a 2-term event. So you should be thinking, in this case, the difference of squares. And that factors, according to our rules, as x minus 5 plus 5. The x gets split, and the 25 is 5 times 5, so we can split it like this. Now, this whole chunk can come out, and that can come out. Those are separate from each other at this point, because it's back into multiplication, as you can see from the signs. This particular one we can't do anything with. It is already in its lowest form, so we're just going to put it down. Here are trinomials. So these are FOIL factored. Our coefficient is 1 on this, so we know we have an x here and an x there. And then we would have to split the last term. That would be in our t-bar, our 10. We're trying to find a factor that adds back to 3. So 1 and 10, 2 and 5. That works. We can use a 2 and a 5. And we're going to need a negative 10, so we can have one of each. The middle term here is a positive, so we know that our largest number has to be the positive. So we're going to have a positive 5 and a negative 2. And our side work is done. This one is also a trinomial. It factors this way. Our x terms go in this position, and we're going to take our 25 to the t. And our factors are 1 and 25. The next one that works is a 5. 5 times 5. Well, that's good. That'll make a 10 in the middle. We need a positive, so the only way we can get these are when our signs are the same with multiplication. And we need a positive in the middle, so both of the 5s are also positive. Now that we have factored as much as we can, we're going to look for a numerator and a denominator with these pieces in them. And I see a positive, x positive 5 and x plus 5 in both the top and the bottom of this, so that can cancel out. Let's see, we also have, look at this, an x minus 2 and an x minus 2 here. It's a top and a bottom, so this can cancel out. And over here, we have a x plus 5 and an x plus 5, so that part can cancel out. This is the lone person that's left. So we would multiply our tops, that's the only thing there, x minus 5, and there's nothing on the bottom, it's all 1. So it's a whole number. Whatever the x is, the last thing that we can do with this is x minus 5. So the multiplication of these two polynomials gives us an answer of that.